Recording has started.
Boom. Okay. So, right. So this is my talk. I'm going to be doing this in Iasi on Saturday. I finally finished it yesterday. I'm hoping it works out, because if it doesn't, I don't really have time to write it again. So I want to do a talk about event sourcing. I'm going to talk about what it is, why you might want to do it, and I'm going to show you how to actually implement it from scratch, so it's not witchcraft anymore. You all know who I am. Don't follow me on Twitter unless you really like Brexit. The code samples and the slides are all up on GitHub if you want to go and look at those. Yeah, that's that. Okay, so what is event sourcing? Event sourcing is an architectural pattern where instead of persisting changes to state, you persist a series of events. Okay, so an architectural pattern is like a high-level design pattern. It's a pattern that you apply to an entire system or an entire set of systems, whereas the design pattern is more focused on individual classes. And what we mean by persisting a series of events is that usually, if you're writing like a Rails app or a Django app or something, and you need to make a change to something, then you fetch some state out of a database, modify that state, and then you save it back with like an update statement. Okay, so if you want to change the name of a user, then you update users, set name equals Fred, where ID is 1, 2, 3, 4. Whereas if you're doing event sourcing, then we don't do that. Instead, what we do is every time we want to record a change, we record a new event. So to change the name of a user, we might have a username changed event or user 1, 2, 3, and we store that in the user events table. Okay? So we never ever go back and update old data. We only ever append new events. So the obvious question is, why the hell would you go and do that when, updating things works perfectly well? And there's a bunch of benefits. So for one thing, it can help us to understand our domains. If we break them down into events, it means that when we're talking to business owners, we can figure out what are the things that happen that make this process work. It has some benefits for testability, because if you show your QA a list of everything that has ever happened in the system, they really like that. But more than that, there are some other benefits. And to demonstrate those, I want you to think about a couple of examples you're probably familiar with. The first one is when you go to the ATM and you see that you've got £1,000 in there and you take out 100 quid. Why don't the bank just update accounts that balance is 900 where account is 1, 2, 3, 4? And the answer is obvious, right? The reason they don't do it is one day they're going to set your balance to something they don't like. It's going to be minus 40 quid, and you're going to walk into the bank with a really mean look on your face. And you're going to be like, dude, where's my money? Like, why am I poor now? What have you done? If you do that, if you go into a bank and you say that, then they'll sit you down on a chair. They'll bring you a cup of coffee and they'll say, well, Mr. Gregory, you did get paid earlier this month, but then you paid your mortgage, and then your wife and children bought trinkets and gewgaws and knickknacks and assorted sundries, and now you have no money left. Now, can you please calm down because you're frightening the other customers? And then you will leave. So banks and accountants more generally store their data as a series of events. And we all know this, right? And the reason they do that is that it's important to maintain a full history of what happened. And you need that because one day the auditors are going to come knocking. And when they say, how much money have you got? And you say, £5, that's no use to them because they can't use that to figure out how much tax you have to pay or what are your kind of legal liabilities are. Okay, so that's banking. Why is Git so awesome? Why is Git so great? I mean, the obvious reason, again, is that you can have a fantastic idea for your code base, and you check out all of the code, and then you stay up till 3 a.m. going hack, 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 hack. And then in the morning, when you're sober, you realize that was a terrible idea. And so you go git revert, and you go, please pretend that thing never happened. Just make that terrible thing I did go away, and Git makes it go away, and your coworkers never find out. So that's good, right? But the other reason, the broader reason why Git is so brilliant is that you can ask it questions, right? You can ask questions like, how did we get to this point? Right? What were the sequence of decisions we took that led us to this design? And you can drill down into one of those decisions and say, what was I thinking when I deleted all that code? Like, what was the reason for that? Like, what was I trying to achieve when I broke this? More than that, though, Git can rewind time, and then we can play it forward again with differences, right? Git rebase is a hugely powerful tool because I can squash things and I can skip commits and I can even edit things on the fly and change history, right? Junior developers write the tests before the code. Senior developers know that you rebase afterwards, so it just looks like you did. Yeah? So why is Git so useful? Well, it's useful because it stores a rich history modeled as a series of events. And because we can then interrogate that event stream, because it captures our intent. It tells us what it was we were trying to do when we made a decision. What were we thinking when we did it? And this is an important idea, and one we'll come back to in a bit. Git applies events, build a working tree. When you do a Git checkout, you start with an empty directory, and then Git applies all of those events one after the other. If you look at a rebase, you'll literally say applying change 1, change 2, change 3. So you never really interact with the events. You only ever interact with a view that's composed by applying those events onto an empty working tree. Yeah? Okay, so you might be thinking, I don't build source control systems or banking applications. I write iPhone apps, and like the last thing I did was an e-commerce site based on WordPress. Like, why do I care about all of this stuff, right? So I want you to imagine a scenario, right? I want you to imagine that you've got your headphones on and you're going hack, 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 like you do. When your boss walks up to you and he says, hey, Bob, which is really weird because your name isn't Bob, but he says, hey, Bob, we're going to build an e-commerce platform, and I want you to write the shopping cart. And you're like, yes, because shopping carts are awesome, right? Every time you learn a new language, the first 3 things you write are hello world, a to-do list application, and a shopping cart. You've got this down. So you get your headphones back on, you're like, hack, 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 hack. And 25 minutes later, you've got a working shopping cart where we store our state as a JSON blob in Mongo, because Mongo is awesome and it scales forever and everybody loves it, right? So this is super simple. It takes 20 minutes to knock up. Everything's great. And the e-commerce site does really well, and your boss is really pleased with you, although he continues to call you Bob, and you get a promotion and a pay rise, and everything's brilliant until a year later when your boss walks over to your desk once more and he says, Bob, we have a problem. And you're like, how can there be a problem, man? Like, I use Mongo and everything. And my shopping cart was awesome. He's like, Bob, no one's buying clocks anymore. You're like, okay. And he says, recently, clock sales have taken a nosedive. Now, the marketing team say that the product page has changed and the UX isn't as good, and so people aren't adding the clocks to their basket. But the UX designer says that the shipping costs have gone up, and so people are getting to checkout and deciding they don't want the clock after all. So what we need to know is, are people not adding clocks to their basket, or are they getting to checkout and then removing them? Can you help us, Bob? I really need to know. So you look up at your boss and you look into his eyes and you say, what, am I psychic? Like, how the hell am I supposed to know? Like, dude, literally all I have is this blob of JSON. How am I supposed to answer that question? Because our JSON blob in this context is completely useless, right? It can't tell us what happened. And the reason for that is we can't distinguish between these 2 cases. In case 1, we create a basket, we add some rocks, we add some clocks, we choose our shipping option, and then we remove the clocks because it's too expensive. And at the end, our basket contains rocks. In the second scenario, all we do is add rocks to our basket and then choose our shipping option. But those 2 cases look exactly the same from the final state. So our JSON blob is useless to it because it only captures the current state. And because it can only capture that current state, it loses valuable data, right? We didn't know that the information that the user removed the clocks was valuable at the time. It turns out to be really critical later on. This happens a lot. And because it loses that data, it can't capture the user intent. It can't go back and go, what were we thinking? What caused the basket to be in this state? Event sourcing is like Git for our domain model, right? It lets us rewind time and ask questions about what happened. Anyone ever done this in production? You need to quickly make a change in production. So you go, right, I'm just going to go in, and you get your headphones on, you go hack, 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 and you write a bit of SQL, and you hit enter, and then you go, oh, I actually ended up doing this. And then you pull this face. I've done this on more than one occasion. And every time it's horrendous, and you spend a long time unpicking it, and you have to go and tell your boss that you've just done a terrible thing. But what if we could just revert that change? What if we could just say to our application, that terrible thing I just did, make it so it never happened? And it would go, okay. What if we could rewind time to reproduce a bug? If you've ever had a bug that you just couldn't reproduce, what if you could just check out your production data from last Tuesday and then play it forward again in slowed motion and watch what happened? And what if we could replay time to make new kinds of report? If when our boss comes to our desk calling us Bob, we can just go and write him a quick function that figures out every time somebody has added a clock and removed it, not just this week and next week, but at any point in our application's history, because we have all of that rich data. Okay? So how is the obvious question, right? So I want to show you how in a bit. I'm actually going to show you how to write an event source shopping cart from scratch, so it's not witchcraft anymore. But first I need to show you a few quick definitions. So firstly, a command is a request to the system to do something. I know you guys all know this shit, so just smile and nod and pretend this is new for you, right? A command is a request to the system to do something, okay? So when I say stand up, that's a command. A command uses the imperative tense. So add item to basket, launch nuclear missiles, those are instances of a command. Whereas an event is a record that the system did something. It's the decision we already made, okay? We use the past tense to name them. So item added to basket or nuclear missile launched are instances of an event. We normally represent events as immutable objects. So in Python, which is my daily bread, I would use a name tuple, and it looks a bit like this. In Haskell or F#, I might do something like this, a kind of record type. In C#, I would do it like this. I just have a class with read-only fields. It doesn't matter what language you're doing, you just want some kind of immutable data structure. There's no behavior to it, it's just a blob of stuff. Then I'm processing a command. It's okay for me to say no. Like if I say stand up, you're allowed to go, dude, I'm just watching your talk. That's weird. Let's stop doing that now, right? Whereas if an event has happened, it has already happened, okay? If the event says nuclear missiles launched, it is no good closing your eyes and saying, la, 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 no, it didn't, because that is an event. It's something that's already occurred. It's too late, okay? One last definition, an aggregate in this, for the purposes of this talk and this talk only, is an event-sourced entity, and we don't need to care too much about it, except that I need to show you some code. So this is an aggregate class I have. It is, actually, can I make this bigger? Probably can, but I need to figure out how. I'll do this. Will it go bigger, bigger, bigger? No. I think there is a way to make it bigger. I'll find out. So this is an aggregate. It is a class that is event-sourced. So all of its state is derived from events. You'll notice that the constructor takes a list of events, like that. And all it does with those events is it replays them. So this is our replay method, and as you see, it just says for every event in my events, apply the event. Where apply is a bit of magic that finds a suitable handler for the event and invokes it with the event. Okay? I'll show you an example of that in a second. There's this write event method, and what that does is it adds the event to a new events collection and to our events, and then it applies it. The reason we have a new events collection is because, remember, the only thing we're going to persist here is events. So what I want to do is when I come to save my aggregate, I'm just going to get the new events, and I'm going to insert them. So I never need to update anything. So by having those two collections, it's just really easy to see what's changed since the last time. So an example, actually no, before I get to the example, this is the most important slide. I stole this description from Jeremy Chassin. You should watch his talks. He is smarter than me and more handsome, and he speaks French. This is how event sourcing works, right? We have some initial state, and we get a command into the system. And based on that command, we make a decision. And then we record our decision as an event, and we apply that event to our state to provide a new state, okay? And then as we go around with a new command and on and on and on, right? So an example, this is a missile silo. You'll notice it is an aggregate. And launch missile is a command. It's a request for the system to do a thing. And the first thing we need to do when we get that command is we need to make sure that the secret code is valid. And if not, then we're just going to raise an error, okay? The second thing we need to do is to make sure we actually have a missile to launch. And if we don't, then again, we're going to raise an error. And lastly, we're going to send a launch signal and then write an event to say we did it. And notice that we send the launch signal inside the decide and not in the apply, right? Which is important. Our apply is here, right? This on missile launched. Whenever we write missile launched, we're going to call this method and we're going to run it with the event. And we're just going to remove that missile from the launchable missile, okay? It's really, really critically important that there are no side effects to the apply method, right? We don't want to send the launch signal in our apply, because otherwise every time you load the missile silo back out the database, we're going to launch a missile again, and that's going to make it really difficult to agree a peace treaty, Okay, really important that applies are side effect free. Okay, so what I'm going to try and do now, I'm going to try and write an event store shopping cart in 25 minutes flat. Show you it's not difficult, it's not witchcraft. Obviously, it's always really hard writing code in front of other human beings. And I'm writing code in front of human beings against a clock. So if I manage to do this, like, you guys go fucking mental, right? That's the deal here, okay? All right, so I'm going to come out of here quickly. Somewhere around here. Where did I put it? Here we go. Okay, so code, play. Won't be called Mongo Basket, it'll have a better name.
I set up a timer, no worries.
Thanks, Joe.
No pressure. No
Okay, need dinner. Okay, so I have some tests. Wow, that's not very big, is it? Edit anyway. Let's make this bigger. That'll do. Okay, so I have some tests. So I've extracted this basket test class, which is a little helper. All this does is make sure that for every test, I create a new basket ID. And it gives me these helpers, event, has event, and raise no events, which make it easier for me to write my assertions. So the event, you will notice, checks that new events contains exactly one event, and then it returns it to me, okay? So our first test case is when creating a new basket. What we're saying is because we create a basket, it should not contain any products. It should raise basket created, which is our event, and it should have the correct basket ID. So the basket at the end should have the right ID, okay? I'm going to run my tests on a continuous loop, so we can see as we start making progress. Now our test fails. Our first test fails because we have no attribute create, okay? So I need to go, I need to add the create method to the basket. Tiny. Okay, so we have the basket, which is an aggregate. And right now, all it has is a constructor, sets up the ID to be empty, and then it has a toString method that just prints the basket. Okay, so far so good. So what I'm going to do is I'm going to add a create method. I'm not going to use the constructor to create a new basket. The reason for that is I'm going to use the constructor later for loading the basket out of the database. So I'm going to pass it a list of events, and I don't want the constructor to be creating new events, but I need a basket created. Do you see what I'm saying? A bit. So what I'm going to do instead is I'm going to have a factory method, a class method on my object. If you're a Java type, then a class method is a static. And I'm going to call this create. It takes the basket ID. And all it's going to do is it's going to create a new basket, like so. And it's going to write basket created event on that, passing the basket ID that we received in our method, and then it's going to return the basket, okay? So we create a new basket, we add a new event to it, and then we return it. Now our test is failing. Got two failures. But the first one we're going to look at is basket object has no attribute is empty. So I'm just going to add that quickly, and because we're doing TDD, we're going to say basket is empty, return true. Okay, so we now have two passing tests and one failing. The one that's failing is we're saying that empty is not equal to this ID we passed in. The reason for that is that although we are writing this event, as you recall from our example, we need to apply that event in order to change our state, okay? So our decide is create, and now we need to write the apply. And I've forgotten which screen I'm on this one. So I'm going to move this up here. Create a new method to apply that event called onCreated. Takes an event, which is a basket created. And all it's going to do is going to say self.id equals event.basketID, okay? So it's just applying the state that we got on the incoming event. And to actually hook that up, I've got this little applies thing that I wrote. And all that does is that whenever we get a basket created event has to apply, this is what it will call, okay? Which is a little bit of witchcraft that makes the event sourcing thing work. So that works. So now we have some passing assertions. What I'm going to do is going to have a look at the test again quickly. That's good. So when we create a basket, it should not contain any products, should raise basket created, it should have the correct basket ID. So far, all good. Okay. So our next suite, if you like, when we're adding a new item. So when we're adding a new item, you'll notice that given an empty basket, we create a basket, and we do that by passing the basket created event. Okay. So because we want a basket that was created previously, we're doing that by passing a list of things that have already happened. Okay, so we'll still only have one new event in the collection. If instead we call basket create again and then basket add item, we'd end up with 2 events in new events, and that's not what we want, right? Is that clear? So because we add an apple, we add 1 apple, the basket should contain 1 apple, it should raise item added, and the event should have basket ID, the product, and the quantity. Straightforward, yeah? So we're going to run that. That's failing because basket doesn't have any attribute add item. So we should add that, which is a decider again, right? So def add item takes self, takes a product. And right now, there's not really any decision to make. You pass me a product, I'm always going to add it. So we're just going to do this. Item added, this takes the basket ID, it takes the product, and it's going to need a quantity. So I'm just going to add that in there now. Item added is not defined. So as I said earlier, we want some kind of immutable object when we're making events. I like to use name tuples in Python. In Python 3.6, you get this nice syntax using the typing module. Product is a string and quantity is an integer. Item added is not defined, but that's not happening in our test. So I need to import that in my test. Item added. Look at that, somebody's already written it. Okay, so now it's failing. It's saying basket object is not subscriptable. It's doing that because we're trying to check that self basket apple is equal to 1. I could go and implement the basket items properly, but I'm lazy and I'm doing TDD strictly. So I'm just going to go in here. I'm going to implement get item, which is a Python magic method for talking to a thing as though it was a dictionary. I'm just going to return 1. Okay, all of my tests are green. So let's go and have a look at the test again very quickly. So when adding a new item, we start off with an empty basket, we add a new item, and we see that it raises item added, and we get the event, and that's cool. Yeah? Next test. Hoorah! So this test, we're going to add an item, but we're going to specify a quantity. So in the previous test up here, we add an apple, wherever we are, down here, we add an apple, but we don't specify a quantity, we just default it to 1. Whereas now we want to actually provide a quantity. So I'm going to run that test, and that test fails because add item doesn't take a quantity. Let's go and fix that. Go in here, let's say quantity equals 1 by default. Then we're going to replace quantity here. So add item added now works, which is great, but it's failing because it's saying the basket should not be empty, but it's still saying the basket is empty. If we look, that's because our isEmpty method is still returning true. So to fix that, I need to actually store the items we're adding. So what I'm going to do is on created, I'm going to say self.values equals a counter, which is like a Python dictionary that stores a count of things. So it defaults to 0 items. If I ask it for the count of foo, and there's no foo in it, it'll just say 0, which makes it easy to work with as a counter. Okay, so self values is counter, and then is empty, you can just return not any self.values. That's still going to fail because I haven't actually got an apply method for my add item. So I'm raising an item added event, but again, I need to go and apply that. So let's do that again. We're going to say def on added, take self and an event, which is an item added event. And we're going to say self.values for event.product equals event.quantity, like so. And that is green other than this one. Is that true? This one is failing. What's failing? Line 81 of test basket. Line 81, not be empty. So when adding an item of quantity, it should not be empty. Why is that failing still? Why? It's because I'm an idiot. So I've written this method and I've forgotten to add applies. Applies item added. And that still fails because the Lord has forsaken me. Okay, so let's see what's going on. Quickly print out my event and make sure that's what I expect. I'm not going to print out the event because I've got tests for the event. In my tests, we check that basket ID is correct, the event product is copied, the event quantity is 3. Definitely applying that because otherwise my basket wouldn't contain 3 items. How can my basket contain 3 items and still be empty? You're right, that's what's failing. Thank you, Ed. I'm an idiot. So this is actually saying it should contain 3 copies, but it doesn't. It only contains 1. Thank you, Ed. You need to come to Yash with me. So get item is returning 1. That's hard-coded. I need to remember that, so I don't do that on stage in Yash. Return self.values for product. And we are green. All tests are green. Okay, so adding an item of quantity, so we know we can add items to a basket, and that works. Okay, so that is enough stuff that I can go and quickly hack together a data access layer, actually demo a basket to you. So what we want to do quickly is go back to baskets. And on the master branch, I wrote a kind of active record pattern. Don't normally do active record patterns, but it's easier to demonstrate. So what we want to do is to get our new events, and we're just going to dump them straight into MongoDB, okay? So to do that, I'm going to say for every event in my new event, I need to turn that event into a dictionary so that I can convert it to JSON. Equals E as dictionary. Then we're going to add the event name, so the name of the event into there. And I'm going to do that so that later on, I know what kind of event it is and I can deserialize it properly. Okay? So I'm just using some weird Python nonsense here where I get the class, the event, and then get the name of the class. So for the item added class, that's going to return me the literal string item added. Yeah? We add that to our dictionary, and then we add our dictionary to formatted events. And right at the end, we go db.baskets.insert data. Not data, formatted events. And we need to spell insert properly. Okay. So we never need to go back and update anything. So we're literally only ever just appending those new events, right? So that's save. I'm also going to write a get, which is going to be a class method. So I can just do basket.get. Exclus, because Python things do, and it takes a basket ID. This one's a little bit more involved if you're not a Python programmer. But we're basically going to say that our data is db.baskets.find, and we want to find all of the events such that the basket ID is the one that we passed in. I'm going to say for each JSON blob in data, we need to get the name, which is going to be the event name property that we added for name, and we need to remove the unique identifier that Mongo adds. So when you save an item into Mongo, Mongo gives it unique ID. I want to remove that. That's going to mess up my constructor. My constructor won't like that, so I'm just going to kill it. And then I'm going to add the what am I going to do now? Now I need to get the class that matches that name. I'm going to do that by just saying globals, which is like a magic global dictionary of things name. And that's going to give me back the class that matches the name. So the item added string gives me the item added class. It means that I can then, events equals a list, I can then insert into my events list passing /JSON. And I know this is very Python-y. Don't worry too much about this if you're not a Python programmer. But at the end of that, I can return basket passing events. Is the dream. Okay, so I'm going to quickly make this a bit bigger, I guess. Quite small. And we're going to go to code play Mongo basket. I'm going to do basket create. I'm going to create a basket containing socks. Give me back a basket with an ID. In theory, I can now do basket get on that ID. And this is going to show me my basket. So we have a basket with this ID. It contains 2 events. We've got a basket created, an item added, and then it's got 1 unit of socks. Okay, so that is working. We have something working where we're storing events and building a state back off there. We're nearly done. We're making progress. Okay, how are we doing on time? The test basket. Next
10
test.
minutes left.
10 minutes left. Amazing. I'm going to smash this, you know, it's going to be awesome. Okay, so next test fixture. When adding more to an existing product, okay? So this is a new scenario. We have a basket created and an item added in our object. One nice thing about event sourcing is it's really easy to create test data because you just give it a set of things that have happened, and that's the only way you can set anything up, right? So it's super easy to create perfect test data. So we create this test data, we add another apple. So we have 2 apples in there, we add 3 apples, we want there to be 5 apples at the end. What's going to run this? It might pass, it depends how I implemented it. I implemented it wrongly. So all I need to do, I think, to fix this is I'm going to go back to baskets. And in my applies method for added, I need to make this plus equals instead of just equals. And then all of my tests are green because I'm a winner. We have another test when adding 0 items. So now we're actually going to make a decision. Okay, we said that we need to make decisions and then apply the results of those decisions. Now we actually have to decide something. What we have to decide is, am I allowed to add this number of items? Maybe you have like some kind of stock checking thing here or whatever it might be. In this instance, we're going to, in our add item, we're going to say if quantity is smaller than 1, then we're going to raise a value error saying quantity must be greater than 0. We're now making a decision, and so all of my tests are green. If we check quickly the test, this is really important. We can assert that we didn't raise any events. And since the only way we can possibly persist any new state is to raise an event, we know for sure that this scenario doesn't change anything persistently at all. So it's quite nice that you can verify that your system doesn't change anything, that the only thing it changes is the thing you wanted it to. Okay, B and maybe G? No, nearly G. Okay, next test fixture. Now we're going to remove an item from our basket. So given a basket, because we have this apple in our basket, we try to remove all apples. It should raise item removed and it should be empty again. Our basket doesn't have a remove because we haven't written it. So we're going to quickly go to baskets. This is another decider. By now you can probably figure out most of these by yourself. We're going to remove self product. We haven't got a decision to make yet. We're just going to say write event. We're going to write a new item removed event. We're going to need the basket ID on there so we can find it again, and we're going to include the product on there so we know what we removed. And that says item removed is not defined, which is true because we haven't defined it. So again, we're going to write a class for that. Class item removed. It's going to be a name tuple. We're going to have basket ID, which is a uuid.uuid. And ignore that. I need to turn that off because that's going to really confuse people. And I have a product, which is a string. I'm also going to need to import that in my test module. So let's quickly do that. And look at that, someone added that one as well. It is my lucky day. Okay, so we're expecting the basket to be empty, but it's not empty. And by now you should realize that the reason that's happening is we aren't applying our removed event. So go back down to our appliers. We're going to add a new applies function, which applies item removed. Def on removed doesn't have to be called on removed, but it makes sense to match the two up. Same, I don't actually need this type signature, it just makes it easier for me to figure out what's going on. And I'm just going to say delete self.values, and I want you to delete the event product. If you've used Redux or anything similar, this might seem vaguely familiar, but we're splitting the notion of raising a command that has side effects from applying the result of that to our state It's basically the same idea. Facebook nicked it off event sourcing. Okay. Not yet. I might do. You might do just so for like reporting purposes, but I don't really need it. The same on basket created, I'd almost certainly have timestamp and the user it belonged to. But for this kind of didactic toy, it's not necessary. Okay, last test case. Our last test case is when we try to remove a product that doesn't exist. So it's the same as before, except that we've added sausages. No, we've added an apple to our basket because we like apples. We're trying to remove sausages, and we want it to fail and not to mark it as empty. So if I go and look at my basket, all I have to do is, and this is again a decision, I want to do it in here. I can say no to the command, and in this case, I'm going to say no if product is not in self.values, then I want to raise a key error. Yeah, so I'm allowed to say no to this command. Couldn't have said no to the event, and that now passes. So all of my tests are now green. Okay, we have a working event source basket. So in theory, I can come back to here. And I can now say basket create rocks, and it gives me back an ID. I can say, come on, basket add docs. No, clocks. Let's add clocks. Why not? Clocks. This basket. Come on. Basket add clocks. Basket add blocks in a box. Basket remove clocks. Okay, so this is the scenario our boss was worried about. Now we can ask for this basket. Although in our basket we're only going to see our rocks and our blocks in a box, we've maintained our full history. So we can always go back and see that our user did go back and removed clocks when they got to checkout. That is my code sample. So I hope that was vaguely useful. You can scan this QR code and do CodeCamp things, but you can't do that because we're not in Yash. I made it in 25 minutes. Boom! Oh yeah, feels good. Okay, questions, I guess. Feedback, flames.
I think this works a lot well, but it's too fast for someone that doesn't know about Python and or the answer. But it's good. I think that the task suite is very nice to explain because of the way that when you explain it's like.
Well, there are things that would have made it clearer. Because so earlier I actually had one that wasn't event source, and I was refactoring that. But I think that was less clear because you couldn't see it build up from nothing. Building it up from nothing makes it easier to grok. But there are some bits that are a bit like, what's this? Like especially like the data access bits. Those are like weird, right?
That get function was like crazy.
Yeah, the get function is crazy. But it's crazy. It is actually crazy in production code. To write it in Python or C# or doesn't matter. It's going to be fucking crazy. Okay. Anything else?
Are they going to know how context works?
No, but I think what's quite nice about context is that you don't really need to because names of things tell you what it's doing, right? So it's just a test.
Did you find it?
Yeah, maybe.
Because I thought it was actually, I prefer PyTest, but I actually found it was like easier to
these demonstration purposes.
Yeah.
Yeah, because it tells you what you're doing, right? Okay.
What kind of audience?
Romanian people. Yash. So it's like a big tech conference in Yash that Pentalog are sponsoring. And so John volunteered me because he's nice like that.